All right, welcome back. And today we are gonna have a different conversation, and the conversation is gonna be about from Kubernetes to AI agents. I know we've come a long way, and today I have with me the honor of speaking with Craig. Hi, welcome on board, Craig.
Hey, thanks for having me on. It's great to have a chance to connect with you.
Just a quick background about Craig. Craig is the co-creator of Kubernetes and a founder of Stacklok, and he is now working on securing AI agents in enterprise environments. So before we get into the conversation, Craig, I generally start with some kind of a backstory or a personal story about how you ended up from co-creating Kubernetes, founding CNCF, the Cloud Native Computing Foundation, to now leading Stacklok. Is there a personal story or a personal backstory or a professional
Yeah,
story? How do you?
I'm happy to take a moment or two to just kind of give you my backstory. Um, I've been in enterprise technology, and I've always sort of self-identified as a platform builder. My first job was working at Microsoft back on it was the sort of Windows clustering technology for NT351. That kind of dates me a little bit. So I've always been in that space. And I think my big break from a career perspective happened when I had a chance to go work at Google. And a friend of mine, Joe Beda, was working on a technology to bring virtualized workloads into Google's infrastructure, basically using kind of virtualization technologies to unlock a new class of workloads. And we kind of had the crazy idea, hey, Amazon just put out this new service called EC2. Maybe Google should have its own kind of enterprise-focused cloud offering as well. And so we worked on a technology that eventually became known as Google Compute Engine, which was obviously the anchor for Google's cloud.
Mhm.
Now, if you know anything about building businesses, you know there's a lot more to building a business than just creating great technology. You also need to build the go-to-market capabilities, and Google was certainly not an enterprise company. So it was almost an act of desperation. From my perspective, I knew that we needed a technology that was disruptive, that would enable us to kind of intermediate our competition with a technology that we could potentially run better on Google's infrastructure. And so we came up with a crazy idea to build out this orchestration technology that was really patterned after the way that Google ran its own workloads, which became Kubernetes. And
Mhm.
I think no one was more surprised than us that it actually worked. You never know how these things are going to go. Um, but Kubernetes worked out pretty well. We started getting a lot of engagement with the project. And, from my perspective, it was pretty clear that for the technology to truly take off, it needed to be a technology that wasn't just owned by Google. We brought a lot of capabilities to the table, but the ambition for what we were trying to do was pretty broad. And I figured that by making it a really kind of community-centric offering, we would have a far better chance of seeing very wide adoption. That would give us an opportunity to then, position Google as an attractive place to run those workloads. And so I started the Cloud Native Computing Foundation as a sort of spiritual home for Kubernetes and as a
Mhm.
way to start bringing together a community of adjacent projects. And that obviously worked out pretty well as well, like the CNCF. And I can't claim credit for that. I mean, obviously, Linux Foundation was incredibly important in the evolution of CNCF. I think that Jim Zemlin's vision for the foundation was as important as the concept of bringing Kubernetes in the first place. I then worked on a few other technologies, built a startup, sold it to VMware. I really enjoyed my time at VMware. It was a great company, great culture.
Yeah.
Got to build some cool things. But at some point, I just got this sort of the itch again, the need to kind of build something, from the ground up. There's nothing more fun than building a startup. And
Right.
I was attracted to the security space with supply chain security, and software supply chain security, thinking through that 80% of the world's software was written by random people on the internet. This was, probably a little
True.
while back, and you probably wanted to know a little bit more about the software that you were consuming. And then AI came along, and it was interesting because it really challenged those core assertions around how people were going to build, operationalize, and consume software. That the technology that we were building was interesting and valuable, but it didn't seem obvious to me that it would be interesting or valuable in 5 years. The world was changing, And so that caused us to really do a lot of sort of exploration around, how do we think the world's changing as you start to bring agentic capabilities into the data center, which is really what anchored us on this new technology we call ToolHive. And it's been really fun to work with a lot of enterprises as they're looking to bring AI-based capabilities into their domains.
Great, great. That's a great piece of background about how you've kind of evolved from Microsoft to Google, working on all these technologies from the Kubernetes era, the infrastructure era, and getting into this agentic AI and the agentic era. I know you have seen, I would say, major waves of transformation in infrastructure space itself. I think apart from a lot of other things going on. So currently, I think before I get into the actual conversation, if there is something you would like to share, what is happening currently with AI coding assistance, right? We in AI agents today that enterprises may not fully appreciate yet. I know because this we keep hearing a lot about these different kinds of coding assistants coming along, the AI agents coming along, and in today's world, with a lot of these enterprises who are not able to fully appreciate it yet. Any thoughts that you would like to share before we get into the actual conversation?
Yeah, I mean, I think it's interesting. I think a lot of enterprises are learning what I think of as this kind of a bit of lesson about the sort of deployment and use of AI. And it's masking, when I say that, what I mean is, enterprises are, engaging with these technologies. They're kind of throwing it out to their engineers. They may be making some investments and trying to kind of apply relatively traditional distributed systems thinking to start
Mhm.
operationalizing the technologies. And they're not necessarily seeing the results, right? And there's this sort of this moment of disillusionment where a lot of folks are, kind of like wondering whether the ROI is there or not. But at the same time, I think that is really masking the truth. This is a profound epoch transition. I think this is a
Mhm.
lot more significant than anything we've seen so far. And the most profound thing is it fundamentally changes, like, not just the tools you're using, but how you work. It's going to force us and force organizations to, fundamentally rethink the roles, the shape of the organization, the way that we are creating value. I always kind of laughingly joke to my engineers is like, congratulations, um, you're all managers. I know none of you wanted to be managers, but whether you like it or
Mhm.
not, you're now managers. And what you're managing is a fleet of agents. And your job is no longer just doing the work with your hands. Your job is now making sure that you're setting up these agents to perform tasks on your behalf and to make sure that they're doing it in a way where ultimately you are accountable for the work product they produce. But you need to kind of rethink that your role and your your uh, your sort of avenue for value creation in the enterprise space. And so there is a profound shift happening. It's going to change the set of the set of skills that create value are changing. The way people think is changing, and frankly, the productivity of teams is becoming fundamentally disrupted. And it's broader than just, hey, use a coding agent. It needs to
Right.
you need to change. This is the way that you plan. This is the way that you synthesize data. This is how you get all this information to these agents so that they can actually start to perform tasks on your behalf, not just in terms of coding, but supporting the whole planning lifecycle. And so it's pretty profound, and there's a lot to unpack there. And I don't think we can kind of hit it all in the opening question, but I think that the sort of the opening point here is they're not just changing the tools you use, they're changing how you work, and they're
Right.
changing the nature of your job in a very fundamental way.
Right. Great that you brought up that aspect of many people may not be really wanting to be a manager, but now with the aspect of these various different AI tools and coding assistants coming across, inherently you end up working or managing these tools. I think you become everybody kind of gets into that kind of a role where you have to manage not a bunch of tasks, but also a bunch of tools, bunch of agents. So that is how the world is evolving.
Yeah,
Let's now get into the, I would like to take one step back and get into this evolution of this engineering evolution itself. And before getting into this AI agents, right? We have had in the software engineering world, we have had automation for quite some time. We have had this scripting, we have this batch scripting, and we used to do quite a lot of these different tools that are automated and all. Now, when we talk about AI agents 20, 25 years down the lane, like when we compare from the late 90s to now, we see things, similar things, but in different ways. Now we have AI agents. What is that it is fundamentally different with AI agents from traditional automation? What are we moving from to put this question, are we moving from something like a scripted systems to autonomous decision making systems? Is that what, or can you elaborate a bit more your thoughts
Yeah,
on that?
I mean, I think it's certainly part of it, right? Like if let's just kind of step back and look at the fundamentals here. You have a new class of system that's been created, and it's a profound thing. Like I think each age of humanity's been named after the dominant technology, like the Stone Age, the Bronze Age, the Iron Age, the Industrial Age, the Digital Age, and we're moving into this new age, which is the age of AI, of reasoning systems that are able to process information and turn data into knowledge, and then turn knowledge into decision, and it's a profound thing. And the way I tend to kind of describe these systems is that they're stochastic systems, like they're like if you think about the world of relatively traditional systems design, certainly entropy shows up in systems, right? And you
Hmm.
you you provide capabilities, and entropy shows up because you need it for cryptographic technologies. It's a desirable thing. Entropy shows up when you're running something at scale. Like if you think back on the Adrian Cocroft, sort of early series on chaos monkeys and
Hmm.
and like running things at scale. There's entropy happens when a distributed system or any kind of system touches the real world. Now, the difference here is that, when you start bringing AI into your world, the entropy is, it's a stochastic system. It's probabilistic by nature.
Hmm.
It's taking, something. It's basically then generating the highest probability, sort of outcome that has the most semantic relevance to the input. But it's a probabilistic process, and so entropy is no longer a function of something that you can't control that the world introduces. Is now something that is natural to the systems that you're building. And everything changes, right? Like I think a lot of people don't realize this. Like I think of a good example of this is what I think of as the agentic lawnmower problem. Organizations don't realize that, like a lawnmower it's a very useful tool. It cuts grass.
Hmm.
But to make it work, you have to push it, right? Like it doesn't just do work by
Right.
itself. And the amount of work associated with getting an agent to start creating, value in a real world environment is significant. The problem is people don't realize that the amount of work to keep it creating value in the world is roughly proportional to that as well, right? Like
Right.
this, you can no longer rely on things like the unit test as a proof of correctness. Like if you way you think about the way that we've built software historically is, people embrace test-driven development if they're reasonably sophisticated. Most people would have some kind of testing framework. You'd run the software, you'd encounter some set of behavior that's not being caught by your test cases. You enhance the test cases, you fix the bug, enhance the test cases, and over time, your test coverage becomes a proof of correctness. So you can, systematically add new capabilities without breaking other capabilities because you've got this test coverage. That is no longer a proof of correctness when you're dealing with stochastic systems. Like it's now
Mhm.
about the world of evaluation cycles and evaluation-driven development. And it just has to fundamentally change the way you think about building and delivering systems. Unfortunately, I think a lot of folks don't necessarily appreciate that the way that you start to reason about value creation is changing, and that a lot of the traditional distributed systems paradigms and patterns just don't naturally apply into this world.
Mhm. Mhm. So here at this point, when we talk about agents or AI agents or agentic um, aspects of this thing, do we make agents work like senior developers or senior engineers, not just like an intern? Because this is where technically and architecturally they are able to make more things work at a much more faster pace. Is that what is the thinking that is
Yeah,
coming
and I,
across?
I think that's exactly right. And I think it comes back to, that earlier comment we had around every engineer now needs to be a manager, right? And you think about like what's
Mhm.
hard about becoming a manager is that you have to give up on doing the work, and you have to start focusing your time and attention on enabling and empowering other people in your organization to do the work. You're still ultimately responsible for the work product that they produce, but you're putting all of your time into making sure that they are doing the work as excellently as possible. And so when you think about the work that's necessary for an engineering team, if you just take something like one of the like Claude Code is a fantastically powerful
Hmm.
system, or Cursor, or VS, like, or Copilot, being projected through VS Code, or
Right.
what have you. It's going to produce software, but that software is going to look exactly like everything else that exists in the training corpus. It doesn't know anything about what you're doing. And so a lot of the work that you have to do as an engineer is effectively context engineering, right? Like you need to establish the context for this tool to be able to start performing tasks in a way that is compatible with your expectations. If you're building, a quantitative trading platform, you can have a very different set of expectations than if you're just, producing a consumer web property. And the act of kind of context engineering is really reasoning about how to start to encapsulate and encompass the context that your team relies on. And a lot of that isn't written down today. This is the problem. A lot of that context is implicitly embedded in the code base, but not necessarily explicitly written somewhere. And so I think a lot of the work that's associated with making this transition into this new world is actually going through the process of formalizing a lot of things that were just implicit, in terms of how things showed up during code review discussions, and people kind of learning via their interactions. And a good acid test for this is, if you hired a new employee into your organization today, how long would it take you to get that person up to speed?
Right.
And for most organizations, it'll take somewhere between a few weeks and a few months, depending on the
True.
complexity of the environment. And a lot of what happens is learning. The person talks to people, interacts, reads documentation, tries to submit a PR, gets kind of beaten up by a staff
Mhm.
engineer on the team, learns the hard way what not to do in PRs, and eventually finds themselves there. Now, by default, agents are stateless. They don't necessarily have this operating memory. A lot of what's necessary to write code that meets your organization standards is implicit. It's not necessarily explicitly written down. And so being able to get to a point where you start, formalizing that, I think the skills concept that's starting to be embraced is a very important construct in the organizational lexicon. I think engineers need to start to self-identify as basically being context engineers, where they're putting a
Mhm.
lot of time and effort into honing the skills, reasoning about the tools. Sometimes tools and skills have to be kind of linked together. There's a sort of semantic coupling that happens. And overwhelmingly, those investments are going to create value. And I think, we've kind of skated by this point where when you think about, how an engineer invests their time, they're
Mhm.
putting, like engineers like to kind of fiddle with tools, right? But you'll go find your favorite IDE, get it set up, figure out what libraries you want to use, get the environment kind of tuned up, and then you just get going, right?
Right.
And then you're productive and you're doing your work. The change is that your work is now constantly managing and tuning that tool set and managing that tool set so that the code that's being produced is not like the work of the same intern that's incredibly productive and never gets tired, but doesn't learn by doing the way that a normal person does. I mean, obviously things are changing pretty quickly with the landscape, but it requires active investments from a team to actually turn these tools into full functioning engineers that can actually complement their day-to-day activities. It also requires a lot of discipline that I think a lot
Right.
of folks are missing.
Right. I think it's great that you brought up the aspects of context engineering because that is becoming more and more prevalent in the age of AI, prompt engineering, context engineering, so on and so forth. I would like to get into this aspect of context engineering, right? I think this is where, when we look into these aspects, like you said, that much of the code that is being written will be similar, but how and where and what is the particular scenario that you use this bunch of code, and how do you make this more relevant to a particular context? So this is becoming more like uh, the new API design for the AI era. So in this aspect, I know many of these enterprise projects or enterprise firms, they are able to they're able to get into this aspect of building quick prototypes or quick POCs. But I think uh, integration into larger systems or larger applications or getting into the productizing phase is taking inherently longer time. And why do you think these enterprise AI projects fail? Is it mainly because of governance or security or integration into these workflows? Or overall, are we lacking this overall architectural thinking itself? What do you
I think there's a lot of different things, right? Like, I think it's trivial to create a system that demos well, right?
Mhm.
Like,
Yeah.
I think back on like, let's just, it's not hard to create an agentic system that demos well. It's incredibly hard to create an agentic system that doesn't go off the rails at least 5% of the time and do something dumb, right?
Right. Right.
Like, and so I think part of the problem is sort of just managing expectations around the class of systems that are being built, right? Like there's an ocean and two continents that sit between something that demos well and something that consistently produces trustworthy results. And
Mhm.
I think that a lot of organizations don't understand the complexity associated with going from something that demos well to going to something that's kind of dialed in, like is kind of honed. Like you start thinking about, hey, I want to have this system and I wanted to look up the customer's kind of information here, and I wanted to, generate a summary and write it over there. And 95% of the time it'll do the right thing, and 5% of the time it'll just do, completely go off the rails and get, it won't even invoke the tool necessary to actually acquire the customer's information because it's a stochastic system.
Mhm.
And I think, enterprises haven't necessarily built out the awareness associated with, evaluation driven development, the need to start creating kind of robust evaluation sets. They don't understand the boundaries and limitations of where static evaluation starts to fall down, and you actually need to start continuously sampling and standing up additional processes to sanity check these things. They're not necessarily aware of the points at which an agentic system will, these self-attention mechanisms are amazing, but eventually they can collapse under the weight of too much context and performance degrades. So there's just a lot of like experiential gaps that exist
Mhm.
as organizations take this on. So that's one arc of capability that I think is missing from organizations. The second arc of capabilities is, these are sharp tools and they get sharper every day.
Right.
And when you think about the world of your existing systems, an enterprise is this fantastically complex combination of people, process, and technology, and you really can't separate them out, right? Like the process is encapsulated in the technology and in the minds of people, and it's relatively slow moving. You go talk to a bank and ask them to draw an architectural diagram. There'll always be a mainframe in there somewhere, right? Like the technology is relatively
Mhm.
stable. And now you're starting to introduce these new systems that are stochastic by nature. And you kind of have to have this. I think about this sort of the need to have an abstraction that sits between the world of what is and the world of what is coming. And you need to start thinking of it as a selectively permeable membrane, right? Like it needs to allow goodness to flow in both directions. Like you need to be able to get data out of your existing systems, but that data has to be sanitized. Like any system you have that has customer or kind of external generated input is a new attack vector for prompt injection attacks, right? If you're
Mhm.
just allowing AI to consume it in an unfettered form. And similarly, the capabilities of these systems are incredibly powerful, but giving them right access to critical systems on day one is probably a really bad idea. And you have to have these systems exposed. So I think the second point of it is kind of a lack of structured governance.
Mhm.
And I think it's very difficult for an organization to. It's one thing to build it's one thing to build a relatively simple system that can be projected for, hey, let's have this thing kind of synthesize data and send out summaries. It's another thing altogether to say, hey, let's have the system actually start to perform actions on behalf of customers in a trustworthy way. And I think that's definitely something that enterprises are struggling with today.
Right. Right. I think you've beautifully laid out where are the pitfalls or what is happening. I think governance and security being one of those prime factors. Of course, whether you take whichever line of business or whichever industry, connecting all these things and how the agents can realistically help build these things. So let's talk a bit about guardrails, right? I think guardrails, this is where uh, when we when we talk about guardrails for a particular AI agent, how should or how would they should look like in a practical, productive environment, whether it is talking about policy enforcement or whether it is about talking about runtime validation or so on and so forth. Any particular thoughts that you have or that you can lay out before we get into the much more details?
Yeah, I think this kind of three anchors for these kind of guardrails. The first anchor I think is critical is identity.
Mhm.
The reality is that when you look at the way that people are setting up a lot of agents today, it's very hard to distinguish. Like if you look at a technology like MCP,
Right.
the Model Context Protocol, which is emerging as a standard for integrating systems. MCP is built around kind of OAuth-based workflows, where the idea is that you have a client, like a coding client, and it's basically a user is logged in there, and they basically provided a credential, and that credential is then flowed across to another system that enables it to kind of access something in the enterprise environment. And the starting point is it's really important to separate out the identity of a human actor that's operating
Mhm.
using traditional systems with an agentic system, and you need to make sure that the set of claims associated with that are scoped to the task at hand. So the sort of minimally scoped claims, being presented with a way that can kind of attribute both who this thing is acting on behalf of, but also identify it as an agentic system. And so I think getting the identity story right and basically having a robust authorization system that is agent aware is a really important starting point. The second point is really about having kind of very rich controls, right? The ability to start at the organizational level, describe policies that apply to every agent that exists in the environment. Like I'm
Mhm.
okay with agents having read access to my AWS resources, but I want no agent to have write access for now until
Mhm.
we
Mhm.
kind of get to a point, and then I want to be able to kind of approve the subset of systems that are able to do that. And so I think having a very rigid and robust boundary between the existing systems and these new systems, and basically forcing the agents to access systems through a relatively controlled interface is the sort of second point. And then I think the third anchor is transparency, observability.
Mhm.
You're going to want to start to institute runtime controls. You're going to want to be able to be able to audit behavior. You're going to want to be able to root cause out an anomalous behavior. You're going to want to be able to set up kind of dead man switches. And all of that requires very high levels of transparency into these systems. They cannot operate in a way that is not allowing an organization to have full visibility into their behavior. And so I think starting with that idea of like get your identity strategy landed, start to reason about kind of authorization through the lens of a controlled set of interfaces that you can kind of have very high determinism around, and then overlaying very rich observability and auditability capabilities is important. Like making sure all of these actions are written into a ledger that can then be kind of audited and reasoned about over time is significant.
Great. I think great that you brought up these points about these three highlights about how do we need to focus on identity as one of the key aspects to understand what is the agent and how the awareness about that, and then getting into the rigid controls, and then finally the the observability of the how transparent it is, right? I think these are the main things. I know you've also talked about something about mentioned about the model context protocol or the MCP as a way for these AI agents to safely access this enterprise data. I know the last month, I believe, with this OpenClaw, which was came out. I think many people across the globe have been trying out. I know it is open source that you could try it out, and I myself was trying it out. And then the second point, which you mentioned, is about the rigid access controls. I think this is where I think when and how and what kind of information that you can give access to these agents is where it kind of brings you many people are now even scared about using some of these tools or
Yeah,
technologies, right? I think I know you're a big propulsion of open source technologies and open source. Before getting into the other aspects, like about your firm, what are your thoughts on this now?
no, I mean, I think it's fascinating, and it's funny because I don't know if the audience is sort of there was a recent blog post around a situation where someone basically stood up a scientific coding agent and
Mm-hmm.
basically said, "Hey, go out there and create value by submitting PRs to open source projects." And the system started basically ended up running a reputation attack on one of the maintainers, right? And it created a huge scene. And it was the psychology of it was fascinating because there were sort of two sides to the story. One was obviously the open source maintainer that basically got to experience this relatively hostile agent kind of trying to submit code and then trying to find ways around the gaps based on the prompt context, but also the psychology of the person that produced it. They went and in their minds they set themselves up by isolating the system, right? So they were like, okay, I'm going to run this thing in a virtual machine environment or on a sort of Mac Mini. I'm going to only give it credentials that um, are distinct from my own. So its behavior is separated from my own. But it never occurred to them. It's like, as these things get smarter, it's like, it's like owning a dog. If you have a
Right.
vicious dog and it bites someone, you're responsible, right? Like you don't get to point to the dog and say, blame the dog, don't blame me. It's like that's not how the law works. And so it's not just about, there's sort of these two facets to it. It's obviously, like I don't want this thing to kind of go crazy and use my credentials to access something and empty my bank account. And I think everyone immediately thinks about that as the primary point of risk.
True.
But they're not necessarily considering the other side, which is you are ultimately accountable for the behavior of the thing that you've built. And I think that, as we as engineers are starting to produce these systems, at the end of the day, our job is going to be about accountability. It's going to be about accountability for the work product that these things are
Mhm.
producing, and that's the thing that we expect. But it's also we're accountable for the behavior of the damn thing. If it starts to behave badly, we're on the hook for it. And so, as I think about the way that people are looking at the world, something like MCP is serving two roles, right? Like, and I
Mhm.
think initially, people got really excited about the first role it was supporting, which is like, hey, here's a way to start describing in natural language or in basic JSON, a way for you to start accessing the tools and information you need to do your job. And that was like putting lightning in a bottle. And I think a lot of people kind of glommed onto that. And it really is paving a path towards what I think of as AI native applications. So,
Mhm.
where, the AI client becomes the presentation there and view model for this kind of new application experience. So you don't have to build UI, you just expose a data source and it can do all that on the fly for you. And that's going to be an amazing world to live in. Will be extraordinarily productive. But there's another side to it, which is it also becomes a control surface. And when
Right.
you are looking at a protocol like MCP, it gives you a relatively clean way to start having really thoughtful decisions around what do I want this thing to be able to do, right? So like I give you an example. Like everyone's terrified, like, hey, I have a coding agent. I built a basic MCP server, and all it's doing is serializing SQL queries, and so it can now run SQL queries against this database, and it deals with the authentication authorization. Well, that's great, but that agent can totally just go drop tables, and your production data is gone, right? Like, but now if you start to formalize the protocol a little bit and start to actually describe the activities you want it to perform, instead of giving it unfettered access using effectively a Turing complete language, you can start to describe the set of tasks that are relevant to the agent in a way that's much more controlled. And so I do think a technology like MCP, and I don't know if it's going to be MCP in the end of the day. Like there's a lot of other, kind of advancements happening in this world, but having that control surface where you can start to be very, very deliberate around these are the things you can access, these are the things you can do, these are the tasks you can perform. And I can now introspect that. I can now start to assert policy against that. I can start to reason about that as a controlled interface. It's just very powerful.
Right. Some of the points I think which really struck me are accountability for work and accountability for behavior, right? I think these are very important and very powerful as well. Like while you're explaining about this, because this is where I think it will define what kind of tasks your agent is supposed to do and how the agent is performing them. But at the end of the day, there is just like how we've mentioned the example of a dog. There is somebody responsible for that, and who's somebody accountable for that at the end of the day. At this point, I believe now I want to get into. I know you have this startup Stacklok. Maybe do you want to explain a bit about Stacklok and what is that differentiation factor? I keep talking about the XTraw AI question or the $1 million question or the $1 billion question that I keep asking in my podcast. What is that differentiation factor that you have with Stacklok, your startup, or your
Yeah,
approach?
so for us, I think it starts with the way I tend to describe this is Anthropic is dreaming of the Emerald City, of this kind of
Mhm.
fantastic futuristic place where everyone wants to live. Someone has to build the yellow brick road to get there, right? So, I think what I think of as being essentially different about Stacklok to a lot of other folks is that we've been very focused on asking the question, where is enterprise today? Where does enterprise want to get? We can see we can see where the Emerald City is. We know what it looks like. And how can we start to apply existing technologies and existing capabilities so that organizations can make progress towards that, right? So when I think about, like our offering in this space, we started with the question like, well, hey, if you want to use an MCP server, what needs to be true about that? Well, if you're an enterprise, it can't be NPX running random software off the internet. Like you can't create exposure to supply chain attacks. And I've certainly seen enterprise organizations that are clients of ours
Mhm.
struggle with this, historically. And so just starting with, basic enterprise sensibilities and enterprise 101s, this needs to run behind your firewall or on your VPC. If you're building a system that's basically unlocking production use of agents against production data, potentially running on a bedrock instance, it cannot be egressing through SaaS. So we've been very focused on starting from where enterprises are, using as many technologies as we think reasonably apply. So I like containers, I like Kubernetes. We start asking the questions, how would you start to make an MCP construct a first-class entity in a Kubernetes environment? How would you go from 1 to 10 to 100 to 1,000 servers? How do you create at-scale operations capabilities? How do you, like obviously there's a lot of excitement about agentic identity, but most organizations are using 1, 2, 3, 4, or 5 existing IDPs, identity
Mhm.
providers. How do you make this work for Okta, for Entra, for the AWS IDP, et cetera? And how do you start to bring these capabilities to make your existing policy frameworks, your existing governance frameworks agent aware versus trying to invalidate what you've already had? So I think the big difference between the way that we think about the world is really starting from where customers are and recognizing where organizations need to be. And then you're not trying to reinvent the wheel, just bringing basic common enterprise sense to the table. Because there's a lot of amazing open source technology out there that, if correctly packaged, operationalized, and presented, solves a lot of these problems for organizations.
Beautiful. I think so. This is where I think, like you mentioned, many customers are in this age of AI very confused and very much. I think many people are trying out different aspects, but the prototyping, they're not able to, 90% of them are not able to move out of the prototyping phase into the productive phase. So this is where Stacklok would come into play, help in transforming them from point A to point B in this
Yeah.
journey. And this
And
is
walking
where
the journey with them. Like
walking
we
the journey
don't
with them.
sell, we try not to sell our product without some amount of applied engineering resources because we've done enough engagements with enterprises to recognize that it's kind of bimodal. Like some organizations get great value, but a lot of
Mhm.
organizations really struggle. And the organizations that struggle are struggling because they don't have the experience to build evaluation frameworks. They don't know when static evals will start to, kind of collapse under their own weight. They don't realize how tools become semantically coupled to, or skills become semantically coupled to tools. They don't realize that eventually, these things are subject to a lot of entropy. And so you need to walk the journey with them. It's not about just telling the story of the Emerald City and saying, hey, come over here. You really need the yellow brick road to get there in the first place.
So in this context, you're helping the customers walk the journey with the frameworks that you have built. Do you have, and of course, you work with um, any kind of LLM providers out there and make sure that irrespective of the technology the customers are using, your technology aware, technology agnostic, and make
Yeah.
the, yeah, do
And
you want to
that's so
expand a bit?
important
Yeah.
because it's so important because it's changing so quickly, right? Like
Mhm.
it's very hard for an enterprise to make a bet on one technology. And there's kind of two reasons for that. One is the state of the art is changing, right? Like every day something new is happening. And a lot of the investments that enterprises make, I think of this as the bitter lesson where,
Mhm.
you go and like, okay, I'm going to fine tune a model. And then, by the time you're done fine tuning it, some new model drops that is already more capable than the fine-tuned version that you've created. And so I think being decoupled because you just cannot make an investment in one specific provider. Just, one of the things that I know you're going to need to do is I don't care
Mhm.
what the system is, you're going to need to be able to identify, authorize, define policy, connect it, isolate the runtime. There's these basic things that are true in any environment that should work. And so you need that flexibility. But the other thing is the switching cost is zero, right? Like this is the thing that I think is so amazing about these technologies is, like you're not, the switching cost to a new model is relatively low. There's,
Right.
now it's true. Once you start building skills, those tend to get a little bit more tuned to environment. Once you start, and I think Anthropic has done amazing work in this regard, right? Like if you look at the way that they've been pushing the envelope around skills definition and structure and projects, they are creating stickiness there. But by and large, a lot of those concepts are relatively easy to translate to other environments. And so I think having an open source core that you can invest in that basically decouples you from these things so that you have optionality and you're not tied to a single ecosystem or model or environment because things change so quickly.
Mhm. So how does the Stacklok stack look like? I think when you are working with these customers, or maybe you can explain in the context of an example. Um, you don't need to name the names of the customers, but any particular scenario you would like to.
Yeah, so for
Yeah.
us, we started our journey just focusing on the MCP connectivity story.
Mhm.
And it always starts with, hey, you need a registry. Like you need to be able to get to a point where your developers can't be running, you can't have random packages being installed by the internet and then being executed by these highly empowered agents without any control. So it always starts with, let's just get your arms around the set of connectors that you
Mhm.
want these things to be able to do. Let's enable you to start to describe policy around how you want these things to be applied, whether running locally or remotely, and get that right. The second thing you then need is a runtime environment. So where do you host these? Sometimes some of them need to be hosted locally, some of them need to be hosted remotely. How do we create a really natural experience where that runtime is a secure environment for these connectors? So you can start to say, hey, I want to run a connector that can access HTTP infrastructure, but I want to limit it to this one URL, and it becomes my documentation server, so that it's much more controlled. Or hey, I want this thing to be able to access file system, but these are the specific volumes I want to be able to mount so that it's not just writing stuff all over my local machine. So the second piece is a hardened runtime. Then you need a virtual gateway. And the reality here is it's not just about having a single endpoint that everything you talk to goes through. It's valuable to be able
Mhm.
to kind of intercept that and observe that. But you also need to be able to start creating a very specific profile of tools that are relevant to a specific agent. So I think of it as a virtual gateway technology. So you can
Mhm.
basically say, hey, this agent, it's going to be connecting using these identities, is going to be presented with this set of tools. And the tools are going to be described this way, and they're going to be filtered this way, and they're going to be optimized so that there's not a lot of kind of context overwhelm. And then you need to create an experience that wraps all of that to manage it. So we've built out a system that does all of that for tools. We've extended that to include skills. And now we're looking at kind of more robust isolation. So you can actually start to create agentic isolation. So when you're running an agent, the tools naturally get projected in, the identity gets projected, and it becomes a whole cloth system for agentic execution. And it's all as familiar as we can make it. So if you have a team that's familiar with Kubernetes, they shouldn't have to learn something new to be able to kind of operationalize and run and scale this thing.
Beautiful, beautiful. I think I like the way you explain it, starting with the registry runtime, and then getting into the virtual gateway aspects of it, and then wrapping it up with what kind of tools you need, what kind of skills you need, and then in the context of agents, how these things should work together. And this is where Stacklok can make things work seamlessly for any customer. Beautiful. I know I love the conversation with you. I know I'm just doing a quick time check before I try to keep my conversations under the 45-minute to 50-minute mark to keep the audience more interested. Before I let you go, I have a couple more questions. What are those 2 or 3 key takeaways you would want the enterprise audience or enterprises remember when deploying any of the AI agents?
I think the first thing is, the existing rules of distributed systems don't fully apply, right? Like you've spent the last, I've spent the last 25, 26, 27 years of my life building platforms and distributed systems. And it's a different world. Like the rules are different. The way that you build is different. The way that the place where value creation happens is different. It's not about drawing lines and boxes and thinking about architecture and then reasoning about the breakpoints from scale and then pulling a single thread through and then eventually enriching it. It's a fundamentally different system where you kind of have to work back from the value story. And it's about a lot of experimentation, and it's about a lot of kind of active tuning. And the tuning doesn't stop at deployment is the key thing. It's like you can't reason about this. If you apply kind of traditional systems thinking to this, where it's like, hey, I just get it running and then I deploy it and then it'll just continue to run and everything's great. That's not how these systems work. The minute you add another tool, you change a tool description, the minute the underlying model changes, the minute that customer behavior changes, like language changes, everything, all bets are off. The minute it reaches a certain point of complexity, all bets are off. And so you have to embrace what I think of as an evaluation-driven development cycle. It needs to be much more kind of thinking about not just the inner loop and outer loop of development, but that loop extends towards kind of production. It has to be something that's actively reasoned about and actively managed, and so you have to be able to drive that. And so I think that's the first takeaway. The second takeaway I'd say is these are sharp tools. And it's not just about accountability for the work product, it's increasingly about accountability for behavior. And I think, this has been wrapped up through the lens of cyber. But there's also this reality is that what's true today is not going to be true tomorrow, right? Like you build a system and it's working fine today and it seems safe. But these reasoning models become increasingly powerful. The tools are just getting sharper and sharper and sharper. And so really thinking hard about the right abstractions, not just in terms of like what's necessary to get a functional agent, but what's the right interfaces to create controls so that I can, I can flow information in a way that's safe, but I can also isolate myself from behavior that's negative. And it really necessitates this least privilege mindset. Like what's the least set of things I can provide to enable this to perform its tasks? How do I create the right sort of isolation so that I'm not just responsible for the work product, but I'm responsible for the ultimate behavior of the system? Is the second big takeaway that I would argue for.
Beautiful, beautiful. I know you have been stressing on this fact about accountability, not only about the work, but also accountability on the behavior aspect of it, because this is where I think things are evolving and things are moving. With that in mind, what do you think what excites you the most in the next 2 to 3 years? I wouldn't say 3 to 5 years, but what excites you the most in the next 2 to 3 years when we talk about the future of AI in aspects of engineering or engineering development or engineering design?
I think it's just like all bets are off. Like all bets are off. Like, we've built out a set of technologies and systems that make assumption about the cost economics of code generation, about the cost economics of code maintenance. So, like, historically, like open source was something that, it was kind of for dabblers, and then you would just rely on, kind of professional organizations to operationalize it. The unit economics for consuming and operationalizing open source are changing, right? Like, all bets are off. And I think it's just this wonderful opportunity where uh, enterprises are going to, like enterprises have long kind of worked, there's this sort of truism that software is eating the world, and a lot of
Mhm.
enterprises have started to identify as software companies. And I think this is going to be a wonderful moment of democratization, where these incredible capabilities are going to be accessible to enterprises, where they're going to be able to start generating IP that serves their customer at a rate that's been unparalleled, where you're not necessarily contingent on a lot of slow-moving, um, monolithic third parties to drive a lot of value for you, because you just don't have the ability to operate things at scale and to kind of operationalize things the way they have. And so I think it's just the fundamental changes to the cost economics of software is profound. And it's, people are learning the hard way. These tools are sharp. It's like, you know, bad code is now free. It used to be
Right.
that bad code you still had to pay for. Now it can be generated for free. And great code is still expensive, but the cost associated with creating good code is coming down as well. Not as quickly as the cost of producing bad code, but it is coming down. And I think if engineers can start to make the mindset transition where they're no longer focused on building the work with their own hands, but they can make that transition to be managers where they're engineering the environment for this team of agents. Their
Mhm.
primary emphasis is the discipline and rigor to actually write stuff down and actually start to describe the problems in an elegant way. It's fantastic. Roles are changing. You don't need like a PM can now produce code, an engineer can now produce specs. Like it's a wonderful democratization force, and it's just super exciting to be a part of it.
Right, right. Like, yeah, completely echo the thoughts that with your thoughts, cost economics are going to be the key factor, and quite a lot of things are going to change. Before I let you go, I think uh, would you give a shout out if people would like to reach out to you about you or your work? How can they reach out?
Yeah, I'm Craig McLuckie. I'm on LinkedIn. I'm always excited to get new connections, and just hit me up there, or check us out at stacklok.com. That's stacklok.com.
Great. Nice talking with you. I learned a lot in this conversation. Thanks for your time, Craig.
Hey, thanks for having me on. I really appreciate it.
Craig, thank you so much for joining us today and for sharing such thoughtful insights with our audience. Your journey from helping create Kubernetes to now working on securing AI agents really highlights an important shift happening in technology today. As AI becomes embedded deeper into enterprise systems, the conversation is no longer just about building smarter models. It is about building responsible systems, secure infrastructure, and trustworthy AI agents that can operate safely in real world environments. What stood out today is the importance of context, security guardrails, and open collaboration as we move toward an AI native engineering world. The lessons from cloud native computing and open source communities are now shaping how we think about AI infrastructure. Thank you again, Craig, for sharing your experience and vision with us. And thank you to everyone listening to XTraw AI, where we continue extracting the raw AI conversations, shaping the future of enterprises and technology. If you enjoyed this episode, please share it with your colleagues and follow the podcast for upcoming conversations with leaders across AI, engineering, and enterprise innovation. Until next time, this is Raghu Banda signing off. Stay curious, stay responsible, and keep building with AI. Happy predicting the future with XTraw AI.